Good afternoon. I will present to you today a simple tool, simple yet effective, I have to say, that we put together in order to aggregate all NGA models and allow, a simple way to use them and compare their results. So this tool consists of an Excel file that combines the 5 models: Abrahamson and Silva, Boren Atkinson, Campbell and Bozornia, Chu and Youngs and Idris. It takes a single set of input parameters and it allows the users to compute a weighted average of the results from all 5 models. You'll find that this tool is particularly useful for engineers who are required to use the deterministic cap, as we saw earlier on today by the building code, for sites located in the near fault regions. It is useful because it also allows the user to compute average in terms of median, median plus 1 standard deviation, and median minus 1 standard deviation. The average can be from 2 or more models. Also, the user can compare the results from individual models. So there are 2 versions of this Excel file. The first version was developed to calculate the weighted average of the spectral values. The second version was developed to calculate the weighted average of the natural logarithm of the spectral values. The difference is, I think, is that calculating weighted average of spectral values rather than of their natural logarithm usually results in larger mean values. And also, since ground motions are log normally distributed, it's probably more appropriate to use the weighted average of their natural logarithm. However, both versions are available and can be used, but I'm going to talk today about version 2. So the input parameters for this Excel file consist first of the weights that need to be given to the different NGA models, and then the user needs to define a set of parameters that would specify the site and the source parameters, such as magnitude, distance, fault type, depth to top of rupture, average shear wave velocity in the top 30 meters of the site profile, and so on. All the input parameters are also explained in the Excel sheet. For output, the user, as I said, will be able to calculate weighted average of 2 or more models. They can look at median, median plus 1 standard deviation, and median minus 1 standard deviation of the 5% damped pseudo-absolute acceleration values. Also, the median spectral displacement values will be provided at different periods. In addition to the table with the results, there will be a plot generated of the 5% damped response spectra in terms of showing the median, median plus sigma, and median minus sigma. This is what the Excel file looks like. This is the main worksheet that contains all input and output data. All the user needs to do is change these cells here, which contain the input parameters, and the results that are the tabular values and the plot are shown here. An explanation of all the parameters used here is shown in this main worksheet if you scroll down. Now, the rest of the worksheets simply contain coefficients and results from individual models. These sheets shouldn't be touched or modified because they will introduce errors in the results shown here. Now, as an example to illustrate the use of this tool, let us consider an earthquake event of magnitude 7.2 that occurs on a strike-slip fault which ruptures up to the ground surface, and with a rupture width of 15 kilometers and a rupture distance of 5 kilometers. And let's assume that the shear wave velocity in the top 30 meters of our site profile is 450 meters per second. Now, the user needs to go to the Excel file and enter these input parameters shown in this table. So for moment magnitude, we have 7.2. For the rupture distance, we have basically 3 different parameters. Our rupture, which is the closest distance from the site to the coseismic rupture. RJB, which is the closest distance from the site to the surface projection of the rupture. And our X, which is horizontal distance from the site to the top of the rupture measured perpendicular to strike. Now, these seem confusing to you, So let's look at simple diagrams that will help us understand them better. These diagrams are from Bob Young's. This is an example of a reverse fault with a site shown as the yellow triangle located on the hanging wall. We can see here the closest distance from the site to the rupture area is the perpendicular from the site to the rupture area. RJB, which is the closest distance from the site to the surface projection of the rupture area, is shown here. Rx again is the distance from the up dip of the rupture area to the site, and it is positive here because the site is located on the hanging wall. Now next we can look at the same type of fault but with the site located on the footwall now, and we can see the closest distance from the site to the rupture area here are RUP, and for this case we have Rx and RJB are equal. But now we have Rx as a negative value because the site is located on the footwall. Now for a strike slip fault, we see again our rupture and Rx and RJB being equal. Now in our particular example, we have the same type of faulting. However, our fault ruptures up to the ground surface. So for our particular example, we have all RUP, Rx, and RJB being equal. And you can see in the table they're equal to 5 kilometers. So for the other parameters, we have to set the unspecified mechanism factor. For our case, it's 0 since our faulting mechanism is specified as strike slip. The reverse faulting factor, normal faulting factor, and hanging wall factor should be 0 in our example because we have a strike slip fault. And the average dip of the rupture plane is 90 degrees. And like I said, since our fault ruptures to the ground surface, depth to top of rupture should be set to 0. Our average shear wave velocity is 450 meters per second, and since it's estimated and not measured, F measured should be set to 0 and not 1. The depth to the 1.0 kilometers per second shear wave velocity horizon is 492 meters, and the depth to 2.5 kilometers per second shear wave velocity horizon is 1.5 kilometers. These are site-specific parameters. Our fault rupture width is 15 kilometers, and the aftershock factor is 0 since our event is main shock in this case. Next, the user needs to specify the weights for the different model. This is here, for example, in order to compute the equally weighted average of the results from all models. We can also decide to give some models higher weight than other models, or choose to use only one particular model by giving a weight of 1 to that model and 0 to the rest. And of course, all these weights should sum to 1. And if they don't, you'll have a flag in Excel telling you to correct the weights. These next slides show the result that can be obtained from this tool. Here we're looking at the 5% damped pseudo-absolute acceleration response spectrum of the equally weighted average. And we see the median in red, the median plus 1 standard deviation in pink, and the median minus 1 standard deviation in blue. This is the same plot shown in log-log scale on the left and in linear scale on the right. Now, we can also choose to look at the values at particular periods. For example, here we're looking at the equally weighted average as median, median plus sigma, and median minus sigma at 0.2 seconds, at 1 second, and at 3 seconds. We can see here that the SA values decrease going from 0.2 to 1 to 3 seconds as we expect. We can also use this tool to look at the results from all 5 models. We have here Abrahamson and Silva in red, Gore and Atkinson in pink, Campbell and Bozornia in dark blue, Chu and Youngs in yellow, and Idris in light blue. This is useful to look at our epistemic uncertainty. And again, this plot is shown in log-log scale on the left, linear on the right. This is for the median values. Now we look at our median plus sigma results at different periods and median minus sigma results. Again, we can choose to look at particular values of the median spectral accelerations at 0.2 seconds, 1 second, and 3 seconds. We can compare the results from all 5 models as well as the equally weighted average and check how similar they are. Finally, this Excel file can be is ready for use and is downloadable at this website here from the peer web page. Thank you.